Okay, so this is AP Statistics, section 2.2, the second part here. We're still dealing with standard normal distributions and calculations. So I just want to run through a couple examples and pick it up from where we left off in the first day. So let's use this as our example here. Again, something that varies normally. The length of human pregnancies follows approximately normal distribution, and with a mean of 266 days and a standard deviation of 16 days. And let's see if we can answer some questions about probabilities and things like that. So first thing you want to do is always get the picture set up. And again, two important things whenever you're talking about normal distribution is we need to know the mean, and we need to know the standard deviation. Okay, and knowing those two things, you can set up the values along the x-axis, and then of course the percentages of values will always follow the empirical rule, the 68. 95, 99, 7. So I went ahead and drew the picture of the distribution. I set these up again. These are going to be days down here. I didn't put the percentages in this time, but of course we should know how to do that from the past couple days. So again, my mean's right in the middle at 266, and then you can see each little interval there has a width of 16 days because that's what the standard deviation was. Okay, so let's take a look at a couple sample questions and see how we're doing with this stuff. Okay, first thing we want to do, this will kind of be a little quick review of what we recapped or what we did the first day. If we wanted to know, what percentage of pregnancies would last less than 260 days, what we really need to do is, if you go back to your picture again, 260 days would fall somewhere in this interval, so it's kind of in between. So we can't just add up percentages because we don't know how much of the piece from 250 to 266 do we include. So the process we talked about yesterday was getting a z-score. So z-score is always going to be the value minus the mean, okay, divided by the standard deviation. In this case was 16. Okay, and make sure if you're doing it on a calculator, get that numerator taken care of first. So it looks like we boil down to -6 up top. When you divide that by 16, you're going to get a negative number 0.375. Okay, so it's negative 0.375. So the way the table works out, okay, is that it rounds to the nearest hundredth. So what I would do is go ahead and just round that to negative 0.38. Okay, now if you were to use negative 0.37, your answer wouldn't be that much different and it wouldn't be a big problem, but technically we'll just round using normal rounding techniques. So what we want to do is look that value up. Okay, that's the z-score. So let's kind of visualize this too before we get into the table. That's saying, if you remember for z-scores, the mean is at 0, negative 250 would represent one standard deviation below. So it would be -1, -2, -3, and of course above the mean would be the positive z-scores. And it should seem reasonable. Our value was, somewhere to the left. It was negative. It wasn't quite to -1. It was not even halfway there. It was negative 0.38. So that seems about reasonable. So if we go to the table now, the table will tell you how much area is to the left of that given z-score. It always deals with areas to the left. So in your table, what we want to do is make sure we're on the negative side. Okay, and again, we're going to find the 10th digit first along the first column there on the far left. So towards the very bottom, you'll see a negative 0.3. And then across the top, we need to go all the way out to 0.08 to get that hundredth digit. And we're going to line those two up. And that's going to give you a probability or an area. So in this case, it looks like I'm getting 0.3520. Okay, so that's how much area is to the left of a z-score of negative 0.38. So that's our answer here. It's 35.2%. Okay, because again, this table works for any standardized normal distribution, and you standardize it by finding the z-score, which is what we did. Okay, so that would be the answer there. So again, looking at it visually, what we really just found was that in the this area over here, Okay, to the left, everything to the left, all the way down, that was about 35% of all of the area in the whole curve. Okay, so that was our first question there, and that was kind of what we did yesterday. So if you're ever asked for a less than problem or shorter than or anything like that, just get the value in the table. It was like 35.2 or whatever, just to be accurate. And the table will give you that information. Okay, so let's change it up a little bit, and let's say, we want to know, for example, what percent of all pregnancies would be longer than 285 days. Okay, so it's going to be kind of a similar process. In a quick little sketch here would show, and when you do these problems, I really encourage you you're going to need to do a sketch. You're going to put the mean in there. Okay, this is still the same issue, so it's still 266. The 285, we'll look at the detailed picture in a second, but the 285 was somewhere way up here. And now we're talking about the probability of it lasting longer. So the longer values are the right tail up here. We're not looking to the left here. Okay, so the process is going to be fairly similar to get started. Okay, if we look at our bigger picture, we'll see again that 285, it actually wasn't quite out as far as I thought, but 285 is about there. And in this case, this question is asking for this area. What percentage of them are more than 285 days? So that area is our question. Okay, so let's see if we can figure that out. We're going to need to get a z-score because it's not one of the nice borderline values. So let's start out with the z-score. Okay, so z-score, just like always, is going to be value minus mean. So minus the 266, we'll divide by the standard deviation. Okay, we're going to need to do that in a calculator, unless you're going to divide by 16 in your head. So I got a 19 in the numerator, divide by 16, I'm going to get 1.1875. And again, let's round it to the nearest hundredth, so let's go 1.19 for our z-score. Okay, that's our z-score. So let's go ahead and look that up. Let's see what the table says for about a 1.19. Okay, I'm going to look up that z-score. So what we're going to do actually is, in the table, okay, again, the 10th digit is 1.1. Make sure you're on the positive side now. Okay, that table has two pieces to it. We're going to go all the way down to the 0.09 to get the hundredth spot. And if we look that value up in the table, I'm seeing a 0.8830. Okay, 0.8830. Okay, so about 88%. Now let's go to our picture here. Okay, does 88% seem to make sense for our blue shaded region up there? Probably doesn't. Okay, and the reason it doesn't is that the table always tells you how much area is to the left of your value. Okay, so again, let me go back to the big picture. What that table entry is how much area is down here. Okay, to the left, that's 88.3%. Okay, so that's one thing you kind of have to know what the question's asking. If it's ever dealing with a greater than problem, you have to do a little bit more work. Okay, the table told me that's 88.3%. I want the green little portion. Okay, so we're going to use the fact that the entire curve is 100%. Okay, we see 88% of it is below, so we're going to have to do a little subtraction problem to finish this question. And that was going to be my last step. Anytime it's a greater than or longer than or anything like that, you're going to take 100% minus that number to get the other side. Okay, so what would that give me? 11.7%. Okay, and that would be the number we're looking for. That's the area up here. Okay, and that's what our question dealt with. So don't rush through them, just make sure we're clear. And if you ever look at the top of the table in your book or in the handout table, it shows you that it's shading to the left all the time. Okay, so make sure we don't skip over that. Okay, so one last case. We've seen where we want to do something, and we want to get left area. The one we just saw was when you want to get the area to the right. What if you want to be in between two values? So what percent of all pregnancies would last in between 260, 270 days? Okay, so that one, again, if we think visually on the picture here, 260 days we know is somewhere around here. 270 days is somewhere about here. And I want to know basically what is the chance of being in between those two. So we're getting kind of this middle, a little interval that's, kind of bounded on both sides. It doesn't go on forever. And again, that's in between 260 and 270 days. So the way to do that is a little bit more work. And here's the thought process. Okay, I'm going to draw a separate little picture. Actually, I'll do this out right here. Think about this. We can find the chances of being less than 270 days. Okay, we can do that. We can just say the z-score for 270. We can look that up. We can get it. We can get a number for this. So the yellow area is less than 270 days. Okay. Now our answer includes some of that, but our answer needs to stop counting and not count the probability of being less than 260 days. So this stuff, just turning that crazy green, is stuff that we don't want to count. Okay, so the green highlighted stuff is the area of less than 260 days. What I want is the stuff in the yellow that we didn't, they didn't get subtracted out by the stuff less than 260 days. So basically what we're going to do is we're going to find what's the probability that it's less than 270 days. Okay, it's going to be its own individual problem. And then we're going to subtract this part here, which was the probability that it's less than 260 days. And it's going to give us that little middle region. Okay, so anytime it's an in-between problem, you're going to do two separate things. And you're going to subtract one from the other. Okay, and that's going to give you your answer. So let's go through and get these set up. Oops, didn't want to go that way. Go back. Okay, so let's first find, what's the chance that it's less than 270 days. Okay, so again, this is the probability of being less than 270 days. Um, so kind of visually, I'm just going to do like a general picture here from 270. Again, I know it's not out that far, but that all of that area is what we just found. That was the 59.87%. But our question didn't want to include everything less than 260. So wherever 260 was, there was some area that was below there that we didn't want to account for because I want to just be in between the two. So the area below 260 was what we actually found in the very first part, right? We did that at the beginning. That was the 35.20%. Okay, so that red area is 35.20%. So our question was asking, what is the chance that we're in between those two? So we really just want this information here. So that's really just the 59.87 take away the 35.20. Okay, and that would give us our final answer. So let's just write that out. Okay, so the stuff in the middle here that we want, again, is the 59.87 minus the stuff that we don't want, the 35.20. And when you subtract those two, you'll get 24.67%. And that should be our final answer there. That's the area in between 260 days and 270 days. Okay, so we've kind of shown now how to do pretty much every case. We started with just doing a less than problem, which just involves going to the z-score table. We've shown a greater than problem, which again involves a z-score, but then you have to subtract from 100 to get area on the right. And then the most complicated is if you're doing an in-between. You have to do two separate problems and do a little subtraction there.